So the blood vessels themselves come in a couple of different varieties. We already mentioned to you we have arteries, carry blood away from the heart. Veins carry blood to the heart. The blood vessels themselves, we look at three distinct tissue layers. The endothelium, endo is inside. The middle is all muscle. And the outer is connective tissue. And essentially this holds everything together for us. So if we look here, the arteries, you notice, have very large levels of smooth muscle, very thick smooth muscle. And remember, this is because the arteries are carrying blood away from the heart, right? And if it's carrying blood away from the heart, it's under pressure. The heart has squeezed, it beat, it forced blood into your body, and it's forcing it into the arteries. And the idea is they're under an extreme amount of pressure from the heart. As we get further away from the heart into these arterioles, these little arteries, we get smaller in diameter. And we get into the capillaries, we get smaller yet. And here we have that mixed blood we've talked about before, that's neither oxygen nor carbon dioxide rich. It's a mix of the two. The capillaries are very interesting. They are very, very small. The diameter of a capillary is 1 red blood cell thick. That is it. So they are going to go single file through here. And we'll talk about why that's important in just a minute. We come back through the capillaries, these capillary beds we call them, into venules. So we're going to collect up the blood from the capillaries in a venule and then send it back to the vein and return it to the heart. Notice here a couple of things about the veins. First, the smooth muscle is smaller. It's not under near as much pressure. When we went single file through the capillary beds, you essentially lost all of your blood pressure. It also has valves. We mentioned valves in your heart to prevent backflow. There are valves in your veins for the exact same reason. If we look at a cross section, you notice the inner diameter of the artery is much smaller. That is because of all of this muscle tissue and all of this connective tissue. The veins, we said about the valves in the veins before. The capillaries we said about being very, very thin, so they're 1 red blood cell thick. And you notice that they don't have muscle. They don't have all of this extra tissue. They are very thin. They are 1 layer of endothelium, 1 layer of cells. And they have something called a basement membrane, which is basically just connective tissue to hold the cells in place. And why are they so small? Well, the capillaries are responsible for all of the diffusion of oxygen and carbon dioxide. Goes through the capillaries. So this is what we're dependent on. The arteries, we said the largest is about 1 inch thick, and that's the aorta in diameter. Arterioles are just small arteries and can get down to about 3 millimeters in diameter, so it's smaller. And when we look at these, they're actually going to have very thick muscular walls, as we saw before. So we actually look at several layers of muscle in the arteries. In the arterioles, we're looking typically at a single layer of muscle. And then when we get down to the capillaries, you would get 1 red blood cell coming through here at a time, single file through that endothelium. Remember, when we look at endothelium, these are epithelial cells. They line things. And for the capillaries, diffusion is what we're most interested in. For the veins, walls are thinner. We saw that. The smaller vessels are actually known as venules, just to confuse you. Sorry about that. Low pressure, so we can have thinner walls. We don't have to deal with the pressure from the heart. And those one-way valves that we talked about. In particular, in your limbs, your extremities, your legs. So as you get older, what we worry about is those valves are no longer as elastic as they were when you were younger, and we worry about the valves not preventing backflow. So older folks are encouraged to put up their feet, typically above the level of their heart at night, to help return those fluids to the heart so you don't get pooling of blood in the feet. Capillaries, we said, are tiny. Average diameter is less than 1 millimeter. That's the equivalent of about 1 red blood cell. Just a little bit bigger, not much. And we form those capillary beds that we mentioned. The idea here is you get a single red blood cell passing through this capillary. Why? We said capillaries needed to do diffusion. That's the big thing, diffusing oxygen and carbon dioxide. If we actually had a vessel where we had many red blood cells trying to squeeze through here at once, the ones in the center would never get to diffuse, only the ones on the outside would. So this process of getting down to 1 red blood cell thick increases surface area so that we can increase the red blood cell contact and diffusion. So moving to and from your heart, we have these capillary beds all over the place. I've shown them to you before in respiration with the alveoli, but every time we move from arteries and arterioles to veins and venules, in between we have capillary beds. They connect them together. So here's an image so you can actually see the red blood cells squeezing through, and as they squeeze through, they're going to get shoved into different directions with these capillary beds. Eventually we'll collect them all back up again in the venules and send them back to your heart through the veins. The whole point, remember, is this diffusion of molecules. We want to diffuse oxygen and carbon dioxide from the tissues and from the cells and supply them with the oxygen that they need while carrying away carbon dioxide and waste. Now, as these red blood cells are squeezing through the capillaries, we saw there is not much to these capillaries. We've got some endothelium. But what we see is as these blood vessels are blood cells are squeezing through the capillaries, they're actually squeezing through so hard that interstitial fluid is leaking out. We said before that interstitial fluid is fluid that contains hormones and glucose and so on that's forced out of plasma. So this is plasma without proteins. It's forced out of the plasma of the blood and into the tissue spaces. So interstitial fluid is fluid between the tissues. Its source is plasma from the blood, just without the proteins. It's still going to carry dissolved things, ions, glucose, and so on, so that we can supply those surrounding tissues with this fluid that contains all of the ions that it needs. So they're going to exchange substances with that interstitial fluid and from the capillaries, and the capillaries will pick back up waste products and send it back to the veins so that it can typically go to the kidneys and get filtered out as much as need be to get rid of the waste. So when we talk about your blood pressure is the force on the vessel walls. This is caused by your heart. This is caused by the cardiac output, which we said was volume per minute, and the resistance of your vessels. So the resistance, what I mean there is twofold. What's the muscle like? Is it good muscle tissue inside the vessels? And are there clots or blockages or plaque? That's going to affect how your heart responds to the conditions and how you can force blood through as need be. The blood pressure, regardless, will decrease as you move away from your heart. We said that the pressure in the veins is actually fairly low. Highest in the arteries, lowest in our veins. We mentioned before this idea of systole and diastole and where we get those two pressures. Your typical blood pressure, typical healthy blood pressure is about 120/70, 120/60, something like that. And what that's measuring is systole over diastole, as we said. So systole, 120. So systole, we said, is ventricular contractions. Diastole is the pressure that's there between contractions, so as the valves close. So if this is ventricle contractions and this is essentially rest state, we want to know what's the pressure on your vessels. We actually measure it as millimeters of mercury. And this is back when there was actually mercury in your blood pressure cuff readings. Now, of course, everything is electronic, so instead it's measuring a little bit differently. But that's where the original pressures came from, measured as millimeters of mercury. When we talk about hypertension or high blood pressure, we're looking at blood pressure that is consistently above 120 or 140/90. Okay. Consistently, not just you're exercising and your blood pressure goes up because you're exercising. Hypertension we worry about because your heart has to work harder. If there's resistance in your blood vessels, if your heart is pumping harder, it weakens your heart over time. We can end up with increased plaque formations because of those ruptures in the capillaries we talked about, increased risk of blood clots, all these things. Contributes to heart attack, stroke, kidney failure, and every one side effect of death. Now, as that blood pressure decreases, we said it's lowest in your veins. Well, that's a problem because you've got veins that have to bring blood back from your big toe to your heart. If blood pressure is low, you're never going to fight against gravity to get it back to your heart. So we're dependent on both muscle contractions in your legs to help squeeze those veins, and we're going to be dependent on the valves. So as you walk around and fidget and move your legs, you're actually helping to return blood to your heart. Now, when we squeeze the muscles, we're actually going to allow the muscles to pinch off those veins, but when we relax the muscles again, the valves are going to open and allow blood to flow in here so that when we contract the muscles again, blood will keep going. So we're essentially squeezing, releasing, squeezing, releasing. So your muscles in your legs are basically pumping blood back to your heart. Pretty cool. Through the use of these one-way valves. So we pump a little bit, the valves close, pump a little bit, valves open, valves close again to keep the backward flow at a minimum. Now, as you get older, these valves weaken, as we said, and we have more complications with this. But in you, they should be good and healthy.